Okay, so we are starting one thing, organizational thing in the beginning. By the end of this webinar, we will run Q&A. I will share a link for questions. If you will have, let's say, other questions outside of this webinar, there will be also email address in the end of this presentation. Okay, so thanks everybody that you found time to come to my webinar today. I'll be speaking about agile craftsmanship and overall what is the relationship in delivering good software. I am Miri, founder and CEO of Flexiana, which is a software development company. This webinar is not going to be all that much about Flexiana. It's going to be more about managing software products, picking technologies, picking techniques, deciding on how the development should be organized, and also what people should learn, which answers the first question, why even think about this? Well-managed development, highly senior developers, craftsmen can develop systems faster, more reliably, and that's a great thing because software is quite expensive, isn't it? Uh, and also I must admit that I have a feeling that in the past it was much cheaper and much faster to develop applications, and nowadays it seems to me that the development actually became a bit slower than it was. Um, Today I'll be speaking about agile and craftsmanship a lot. Let me give you just super quick definition of how I will see agile in this talk. There might be plenty of definitions that go further beyond Agile Manifesto and 12 principles. So let's say fast iterations, being in touch with the customer, being not only able, but being willing to change every time you learn something new about the product you are building, about users, and about things you have to deliver. So let's say Agile is from my point of view, Agile is a mindset or a culture, but at the same time, it's a set of techniques that should enable all this. These techniques might be more managerial, if you will. So there might be things related to daily stand-ups. There might be spike solutions. There might be prototyping, having a customer in your office sitting with you daily or almost daily. All of those things fall into or under Agile umbrella. Um, Another thing is Agile the same thing as software craftsmanship? From my point of view, it's not. Agile is more focused towards, let's say, skills that help you to deliver more useful product by being more adaptive, more flexible, and more pro-customer, while craftsmanship is helping you to deliver better software faster by building hard skills. So from my point of view, software craftsmanship is a lot of focus on mastery of programming languages, IDs, and so on. When you will speak about, or when you will hear people speak about software craftsmanship and software craftsmen, very often I see that people speak about clean code. Even myself, when I speak about software craftsmanship, very often, like in just a few sentences, I get to speak about clean code because it's very, let's say, related. But at the same time, one of the things you will learn in this webinar is that actually software craftsman might be a person who sometimes might write ugly code, terrible code, and it might be a good thing. Now, we will begin with a little bit of theory. So the first thing is an article that's inspiring and that's setting up the stage to think about craftsmanship and software development. And it's an article called "The Rise of Worse is Better." which describes, let's say, two approaches to software development. One approach is called MIT or Stanford style, which is very correct. And then there is, let's say, the versus better philosophy. The article is quite long. It's easy to find on internet. There is a link also in the presentation. So I recommend reading it, but I made a quick summary of the differences of MIT Stanford style and versus better approach. So in the Stanford style or MIT style, you are trying to implement software that from all, let's say, outer perspectives is perfect. It's simple. It's correct, which means um, that it can't run into, let's say, branches or situations that are unacceptable. The behavior and the design is always consistent, and the tool or the application should cover the whole domain. While versus better approach is basically uh, as an approach to software development where you make it much easier for yourself. So you are trying to write the code that's simpler for you, even if it means that the interface for users might not be that perfect. And you might be way more productive, even when sometimes the behavior will be unexpected and the design will be inconsistent. Now, when you think about it, uh, how does it rely to craftsmanship? So is MIT style and or Stanford style craftsmanship and versus better is not, or is versus better craftsmanship and Stanford style is not? So if you ask me, I would say that, and the outcome of this presentation is both might be craftsmanship, but they have to be used at the right time and in the right situation. So this is one thing that's important for today's call and to understand the theory I'm coming up with. The second thing is this. So SA is Sharpe ratio. Sharpe ratio is used in financial management, in portfolio management, and it basically tells you that you have RI is, let's say, certain expected outcome. Let's say it might be higher productivity in software development. It might be more money you will earn or money you will save because you will have less bugs in your software because you write more tests. And you compare it with not doing that, not doing the change. But an important thing to understand is that every single thing you do has risks and costs. But let's say in a Sharpe ratio, we think about the risks. You might have two technologies where one technology might give you a huge advantage over other technology. Still, its Sharpe ratio might be worse because the technology might be more risky. Um, when uh, when Tim mentioned closure, yes. For example, in the beginning, a decade ago, adopting closure was a huge risk, and you and first developers who were jumping on closure, they're doing a huge risk. Nowadays, when the language is 15 years old, it's not all that risky. So basically, the value stays the same or even is getting better while the risk is going down. So the payoff is coming up. And you might have mainstream technologies where sometimes payoff might not be that big, but risk might be absolutely minimal, and you might be quite sure that you will be able to deliver the software at certain time and budget. And when you look at it, all of those techniques that exist, and it might be databases, programming languages, testing approaches, it might be the way how you organize the team. All of them have certain, let's say, and you have to choose sometimes. In many situations, you have to choose, will I use just Postgres or Mongo, or Postgres and Mongo, for example. And when you look at those options, each of them has certain advantages and certain risks. I would say, for example, Postgres has a lot of value, very low risk. Mongo has more value in certain situation, but it's more risky. And the combination of Postgres and Mongo actually is the most risky approach, while the payoff might not be that high. So when you look at that, you can basically say there is a frontier, and at that frontier sits the best combination of technologies, methodologies, techniques, approaches to your code base, software architecture, and so on. The problem is that each product is different. Each product evolves over time. Each team is different. And when you are highly senior at certain technology, you basically might leverage the full value of that technology, which provides higher RA, while you de-risk the thing because you have already done many or majority of the mistakes you could do, and you know how to think. So um, now I'll get back. So at this point, I would say that basically people who are building software are buying, in a way, techniques, methodologies, technologies, and their goal is to optimize for the highest SA over time. And let's say, when I say over time, you might be looking at current situation, you might be looking at, let's say, short-term situation of the team. So let's say upcoming 3 months, upcoming 1 year, but you might be also looking at the total projected longevity of the product you are building, which, for example, in B2B apps can be easily 15 or more years. And during that time, the team might change and it's difficult. And sometimes what is great at the beginning might not be that good over time. Now, I will show you a couple of charts, which are, let's say, estimates of SA Sharpe ratio for certain aspects of development: front-end development, back-end development, craftsmanship, agile, software architecture, and DevOps. And in those, I will be, I have created super simplified model where on one axis I have expected Sharpe ratio, and on the other axis I have the team size on Fibonacci scale. Of course, the team size is just an approximative metric, because sometimes it might not be that much correlated to the team size, or it will be correlated, but not that much, not highly, because, for example, you might be deciding based on how much data you have, how many requests you get, how many users you have, how much you are regulated, for example. So all of those things can shift it. However, then you will be deciding what to adopt, what agile techniques to use, what craftsmanship techniques to use. Try to build such a model in your mind when you will be choosing. That's the point of this presentation. So let's speak about front-end technology. So on the axis X, we have team size. So we start with just one developer on the project, and the team grows to 144. We could continue with the Fibonacci scale. So nobody's using jQuery, right? Actually, but it might be a mistake, because for the super early stage, and when you know that the technology will never grow, and the technology, the product you are building does not have to be, let's say, does not have a lot of logic on front end. It might be great to use jQuery when you are one, two, three, four developers, but I doubt it's a good decision for a team of 20, let's say. Uh, there's another interesting technology is ATMX. I hope some of you know it. So it's basically an enhancement, progressive enhancement for templates, where you basically write templates that look like just backend templates, and HTMX refreshes pages, replaces parts of HTML with snippets snippets of HTML that have been built on backend. One thing I have I have learned is basically that HTMX is seen completely differently by uh, let's say experienced front-end developers or full stack developers, and people who are leaning heavily towards backend development. People who are backend developers and who want to do as little front-end development as possible, for them, HTMX is a godsend and they like it a lot. While experienced front-end developer, when such a person might not have a chance to, let's say, pick React, Vue.js, for example, he will be happier with just vanilla JavaScript over HTMX. However, as the project grows, vanilla JavaScript gets worse and worse over time, because even when you can implement anything in vanilla JavaScript, you will end up with your own custom architecture. And when you will be hiring new people to the team, it's more difficult to teach them everything. While frameworks like React, which I think is perfectly okay for big projects, when you are Facebook, React is great. While with small teams, it's actually overused. And then we can look at ClojureScript. So ClojureScript is great when JavaScript jQuery stops being useful. At the same time, there is, let's say, certain, as of now, as of 2024, there is certain amount of experienced ClojureScript developers in the world. And I would say for almost any company that wants to do ClojureScript, they can build a team of, let's say, 10 to 20 people. And when they want to hire, let's say, 50, 80, 100 developers, they will have very hard time finding them. And suddenly, even when the technology is capable, HR might become a bottleneck. While technologies like React and on let's say a lower level of magnitude, but still significantly larger than ClojureScript, will be Vue.js, Svelte, um, and other frameworks that are popular nowadays. Even Angular, modern Angular is not bad. So let's say you will have much easier time hiring developers for React or Vue when you need to hire 100 front-end developers. But how many companies need front-end developers? Now let's look at backend development. So if any of you have worked with those classic MVC frameworks like Ruby on Rails, Django, Laravel, Symfony, .NET MVC, those frameworks initially give you extremely high productivity, and in the first 20 hours, it looks like you finished 80% of your application, especially if the application is mainly focused on handling data entry, data grades, and so on. So, for example, in Django, you use Django tables, Django filters. It has middlewares to keep users being logged in. There is a feature to create sign-in form. You just import it. It's in the framework. So in the beginning, you can hack plenty of things extremely fast. But over time, you have to hack the framework, you have to change it, and you are running into situation when it's more difficult. Um, I'm not speaking about Spring Boot, which would have probably a very interesting shape of SA or sharp ratio. Now, the second is Spring Framework. Let's say enterprise framework. Mainly, let's say Spring Boot might change it, but it's it's great when you are building banking software, let's say, and it might be super useful because you will always, like when you are in a large city, there will be hundreds of Java developers who can work on site in your office, and you could potentially hire them. It might not be cheap, but they exist. You don't have to hire people globally, have a full remote team, because you can just hire people in your city because they will be there and they will be capable to build systems that have hundreds of thousands of lines of code. Uh, let's put all jokes aside on that. What is hundreds of thousands of lines of code in Java might be tens of thousands of lines of code in Clojure, even when it's true. And now when we are looking at Clojure, Node.js, so when you look at that, these technologies might have good payoff. I would say Clojure has a very high payoff, but if you don't know it, the ratio is worse because it's more risky. And again, we are getting at certain situations where HR might become your bottleneck. So most companies, when they work in Clojure, they tend to be of certain size. Most of the time, it's really 5 people plus. But except Nubank, I have never seen a team of Clojure developers that has been over 100 people. Nubank is let's say a huge, let's say um, a unicorn, if you want. Now let's jump to Agile. So um, I have nothing for one or two people, 1, 2, 3 people, because there is basically a methodology. I think it has a Wikipedia page. We used to call it cowboy coding. Cowboy coding is when you just start building. Ideally, you have customer on site, you release constantly, but there is almost no methodology. Maybe you have some README file and everybody's just editing README file with all features or change log, and that's it. That's the whole methodology. But over time, you might end up learning that it's not working for you. Now, Scrum is often hated. It's often hated for good reasons and often hated for bad reasons. Well implemented Scrum, or let's say each agile methodology, has to be seen as the point in time. When you say we do Scrum, and there is a, let's say, Scrum by the book, which has certain terminology, certain roles, certain rituals, you shouldn't stick to those rituals, terminology, and roles forever. Implementing Scrum is just point in time. So you implement it, which means before you had no system, it was all ad hoc. So you adopt something, it pushes you to have proper backlog, meet up, plan your work, do a retrospective, speak every day about what's being done. Having somebody who is responsible for the backlog, like writing tasks, splitting them to smaller ones, and so on. And all of those things are great things. The problem is that people don't customize Scrum. So let's say good Scrum is actually Scrum when you go through adoption and then you build something yours. Scrum has certain disadvantage in, let's say, huge projects or small or larger projects, because first, it doesn't scale all that well. There are plenty of attempts to scale it, but overall it's not easy. And the second thing is when the products grow, very often the task size grows. It's not a good thing, but sometimes it's just a necessary thing, and you can't split the task to be a couple of hours. And in that situation, shape up methodology might be a good replacement. Shape up is a methodology where you basically have 6 weeks. Again, take every methodology just to be a point in time. You say, okay, today we adopted Shape Up, and tomorrow we will ask how to abandon it, how to improve it and make it ours. So when I speak about Shape Up, I don't say that you should stick with a Shape Up forever. So basically, you work for 6 weeks. You have a couple of big features and a couple of smaller features. Initially, you do some preparation work. Then for about 4 weeks, you work to deliver those big features and a couple of small ones. And in the end, you do some cleaning up, refactoring, fine-tuning, and you release. When you have 6 teams in your company, you might have 6 shape-ups running at the same time. If you do that, I would recommend against having synchronized shape-ups because you might end up with massive releases that have thousands of commits every 6 weeks, which is a classic anti-pattern in software management. It's much better to have them out of sync. So, for example, every week you release something new, which of course pushes teams to integrate, to do continuous integration, which is a good thing anyway. Then there might be other methodologies like holocracy that is somewhere between liquid democracy and having architecture, having organizational architecture where people work as teams without team leads and without managers, yet they are able to decide as teams. But this is something that if you don't work at companies that's like 100 developers plus, it will be meaningless, and you need something that's much simpler. Then let's not speak about methodologies, let's speak about agile techniques. So, for example, customer on site is always useful, but over time it gets more useful because you get more work done. Like imagine you have just one developer working on a code. It's super useful for the developer to have somebody to ask at all moments, but for the customer or the customer's employee, it would be a huge waste of time because one developer does not generate enough questions. But as the team grows, its value is coming up because there is more work being done, more work that needs clarification, explanations, etc. Spike solutions. So initially, there is no need for spike solutions because everything you do is basically a spike solution. But over time, as those big projects turn into, let's say, more massive things, people might get scared of building quick prototypes, and pushing them to do so might be super useful. Also, what I have seen at big companies, product owners often end up being super busy. I have seen companies that where product owner was in the USA while the team was in Europe, and the team had just a short overlap because the product owner was on the West Coast, and it was one company. It was American company with a branch, a development branch in the Czech Republic, and basically their product owner in the USA had had basically 2 hours overlap with the Czech team, and it didn't work all that well. So what they did, they decided to have a proxy product owner. They hired a guy who was from that field, He was Canadian. He shadowed for the product owner in the USA, and after a while, they sent him to Europe. And it actually, even then, they had to pay one extra salary, they had to manage one extra person. The productivity of the team, of the whole team, went up a lot because they didn't have to wait for plenty of replies. And the proxy product owner, even when he was just basically trying to think what the guy in the USA would think, would still was still really good because he was from the field. The product was highly technical, but still it needed a lot of domain knowledge, and developers didn't have the domain knowledge because even the domain was in tech, it wasn't just software. So it was tricky. Having a proxy product owner has helped. It was positive. It was good investment, let's say. Now, craftsmanship. So for craftsmanship, I would say having good knowledge of your programming language is always super useful. And each person who calls himself or herself software craftsman should constantly work to reach programming language mastery, no matter if the language is functional programming language, object-oriented language. This will pay off in every company size, in every team size. Another thing is IDE mastery might be, it's not just IDE, let's take it as an example. You might have additional tools that go on top of programming language, like IDE mastery, framework mastery, testing library mastery, and for all of those things, I would say it's useful, even no matter if you are on a small project, in a small team, or large project, a large team. So building software craftsmanship, if you ask me, is first and foremost building expert knowledge of your programming language and the most important tools you use every day. Then when we look at clean code, which gets us back to worse is better. So when you have a small team and you iterate fast and you are learning what will be needed, clean code might be less useful than ability to hack extremely fast. But at certain size, at certain team size, and in my chart, the cut is at around 2 3 people, which in the real world might be more like 4 5 people. Ability to hack extremely fast, payoff goes down, and writing clean code, even when you will be somewhat small or slower, is is worse. And you need to learn how to write really clean code, how to refactor, how to name things, how to split things to smaller ones. So this is, let's say, software craftsmanship. Now let's jump to ops and DevOps. So I will be showing a couple of technologies nobody is using anymore, right? Bash script and rsync and Ansible and so on. So, and again, it depends on the type of project. Here, team size might be the worst axis I could have picked because it's more about the user base size, data size, how many machines you have size, and so on. But let's say approximately when you are just one person, and if you don't know Ansible, SaltStack, Kubernetes already, having just a bash script and rsync might be the best solution because you are still in the hacking mode. But very quickly, it's not the best solution anymore, and it's better to replace it with something else. Now, tools like Ansible, I think, are underused nowadays because teams are moving to, let's say, other technologies that are more scalable. Now, very often people speak about pets versus cattle. So, pets is when you name your servers and your devices you use, when you name your databases. So you care about them, uh, they are unique, and you maintain them. While when you have kettle approach, you might spin off 100 new servers, 20 new instances of some database or um, Redis, and get some caching, let's say, service. But the kettle approach has disadvantages. It's slower to set up. It creates vendor lock with one cloud most often. It might not, but if not, you need somebody who is an expert to set it up. And usually it's extremely expensive. Then, so at Flexiana, we have a mix of situations. We have our own servers, but we are using also all major clouds. And I must say, when we work with our own server, the ROI is like 5 to 1 by not using cloud for plenty of things. And you can use Ansible very easily to install things. Nowadays, everything is in Docker, isn't it? But it doesn't have to be. So solutions like this means that you can download existing recipes. You can add them to your code base, to some repository, maybe sprinkle it with a little bit of configuration, and you're done. And it just works. So I'd say it's a good thing to have when you have small to mid-sized team, but over time, as time goes and the team grows, it might be the best solution to move away from the land of pets more towards the land of kettle. No matter if it's a real cloud or if you will build your own private cloud, but still it's good to have such a thing. Unrelated to provisioning, there might be things like, for example, feature toggles. In the small team, you don't need feature toggles. Basically, what you build, you immediately deliver for all of your customers. You are so fast that if you mess up, you just roll back your release. If you are one person, you are basically living with your code. And when you go on a holiday, there are no changes in the product. So you don't need to turn off certain feature. While over time, as time goes, it might be better to actually have a chance to replace some features or turn off certain features. Now, software architecture. So for a software architecture, again, using team size is it's not a very good metric, but still, let's play this game. So you have monolith, modular monolith, polylith, microservices. So when you look at monolith, it's underused. Microservices are probably overused, and everything else is not used, which is a shame. So if we speak about monolith, we really like monolith is an architecture where there are a couple of rules. First thing is basically everything is one repository. It's launched and compiled by one command. Quite often, you have just, let's say, one process running. If you have multiple processes that are being run at the same time, all of those processes were started by the process that you turn the application on, and the source code of all of those processes is most likely part of the same repository. And at the same time, in monolith architecture, any part of the application can call any function anywhere else in the whole application. So everything is interconnected. And it works quite well, I would say, for certain sizes of projects, certain sizes of teams. But over time, it might become a little bit messy. Again, when you do refactoring, when you care about clean code, you might go for a long time with monolith and it might be perfectly okay. But if we speak about big applications, let's say a team of 20 who are building application for years, you are well into a land of hundreds of thousands of lines of code. And at that moment, it might be difficult uh, to actually maintain the whole thing and map out what speaks with what, and it's not easy anymore to reason about the system. Now, so we are getting into modular monolith, which means basically you have modules within your code base, and these modules have certain interfaces. And when you want to communicate with this part of the code, you do it through those public interfaces, and everything else is hidden behind, which of course makes the system more maintainable, but the code is larger because you need to go through gatekeepers, you need to build gatekeepers, you need to define their behaviors, their interfaces, and you may have to maintain those forever, basically. So modular approach works, and it makes your application, let's say, more maintainable at certain size. Like when you stop thinking as like having just one horizontal layer where you have a bunch of monoliths that or modules that speak to each other. And when you also create modules within your modules, you will end up with polylith, which makes it even more scalable, but you have even more gatekeepers. There are some existing solutions for Clojure and Python, which you can use uh, to scale your application. At the same time, you have to think that in your architecture, you suddenly have more, let's say, moving parts. Even when still you might have monorepo, you still might be compiling the whole application in one step. It might be potentially one process running, which has plenty of advantages. And now we are looking at microservices. So back in the day, there was something called service-oriented architecture, um, which was very popular uh, in the end of 90s. There was before REST API and XML RPC. There were SOAP API. So basically, we were sending XML over APIs, over requests, where you were basically calling methods in other applications that were running in parallel. Nowadays, we have microservices, which is more modern approach. Everyone who worked with SOAP run into plenty of scenarios or situations where it was terrible, like all SOAP. SOAP was supposed to be language agnostic, yet you ended up with situations where SOAP requests sent from .NET didn't work in PHP, for example, and vice versa. I have witnessed this when I was working with SOAP. Microservices simplify this. You either use event sourcing or REST API, very often with some async interface. But the problem is that suddenly your application is not one process and you don't have a chance to touch everything at the same time. Now suddenly this happened. Now for some reason, for some reason, and the reason is you have multiple processes, your processes can fail. Your network might not be available at the moment. And suddenly you have to think, okay, what will happen if I can't reach another microservice? This is impossible. In monolith, in modular or polylith architecture, you can always call other parts of the application, like every single time, 100% of cases. In microservices, it's not the case. It's harder to reason about when things are being done or are being called in certain ordering and so on. So, so actually, microservices have plenty of disadvantages, but they give you ultimate scalability, and especially if they are connected with that kettle approach, You could potentially build architectures that can scale from 10 users and paying nothing for a cloud to millions of users and paying exactly what you use. And and it works for certain companies. What I would say the cutoff for microservices is at usually much larger projects that they are used now. And for, let's say, 3/4 of companies who are adopting microservices, I would recommend them to look at modules or monolith instead. So this is software architecture. Now let's jump to, let's say, some case study example project. Let's think that we might have some ERP that you develop for a company or multiple companies that will depend on this ERP for some of their processes. Again, it's just a model. Your situation might be different, and you should always customize things based on your evaluation of the situation. So let's say first step, stage one, you're just one developer. One thing I recommend when you are starting new development, even when you know that ultimately it will be a huge thing, there will be 100 plus developers working on that. I still recommend starting with very small team, 1, 2, 3 developers initially, and grow, let's say, initially slowly, get everyone productive. And then when you have 3 people at maybe two, when you have 5 people at maybe another two, when you have 7 people at three, like it is exponential growth, but initially it looks like it's not. So we have stage one, and you just focus on speed and you work with the customer, speak with the customer all the time. That's the agile thing. And from craftsmanship, so you have reasonable clean code and readable code, simple architecture, which at this moment might mean it will be monolith. Then you grow to, let's say, 2 people. So instead of just having some markdown file saved somewhere in the hard drive, if it's a good project in the repository directly, you implement something like Trello, Notion for tasks. You don't do a lot of ceremonies. You don't have any uh, daily stand-ups. You don't have any weekly plannings. You don't have any retrospectives, nothing like that. You still keep speaking with the customer, and the team is, let's say, bonding together with pair programming sessions and is growing to, let's say, 3 people, and the system is launched, maybe hundreds of users are using it in the company. It might be some data entry thing, logistic thing, and so on. So still keep everything very simple. I would not implement nothing like Scrum at this stage, not even Shape Up or larger methodology. Um, and maybe you can start thinking how to split the application into multiple sub applications. Still, it's just one app, one process, one code base, one repository, and then you continue and you start adding more people. So now you have, for example, 10 developers. At this moment, it might be, when I speak about Holacracy inspired, I mean inspired, still very lean, very simple framework, maybe Scrum, maybe of something yours. Uh, at this stage, you probably should have the application split from monolith into modules, still in one code base, and you add more refactoring to your code base to make it, or to still keep it clean. And then you grow to even larger projects. You have 20 people, 300,000 lines of code. The application is business critical for one or more companies. And in this case, you are really moving towards more scalable methodology like Holacracy. You have module architecture. At this case, at this stage, you don't have monolith anymore. and you focus on a shift towards all of those things. uh, Stage 6, let's say, you are getting there, you have covered the whole process or processes of the whole application. So you keep refactoring, keep quality. Um, the company relies on you, so you need the application to run all the time. So you add plenty of tests, you do security testing. All those things are more important than they were at previous stages. Then let's say another stage might be the most boring one in software development. It's major software. It describes the company well. The company might be changing, but it's not changing that much. The company knows exactly what it expects from the tool, so you just maintain it. Quality is more important than productivity at that stage. Uh, and then, let's say, after the system has 15 years, you are getting to the point where it's a good time to build a new generation of the system. There are um, new versions. You might want to change the technology. The company has changed. The company might be merging, or there might be a tool, an application that costs you nothing, that did not exist 15 years ago, and now you can just use some existing application that you will buy for 10% of what you have to invest into maintenance of this application per year. So you might swap. So if you are using existing product, it's different. But if you are building new version, a good way is to build some form of a save where you basically have the old system and the new system running at the same time. So uh, it depends if there is an API between front and back end. If there is, you keep the same API. This gives you a facade. You need to implement share user access, user accounts, and when you are signed into one application, you are signed into the second application as well. And over time, as you keep the API, you replace the old application with the new application, and you just carry on doing all of those good things like writing clean code, do all of those things that were always on the right side of the chart, but knowing that if there are features in the application that are not used, you can remove them, which means it might be smaller application. You might be living with a little bit smaller team. While having a smaller team, other things, other technologies might be more advantageous for you. So this is a quick summary. I think everybody remembers that. So let's jump in, and I need to do obligatory joke. It is quite possible that there are PHP and jQuery developers being very rich and coming home in Lamborghinis because at, let's say, small or mid-size projects, somebody who is just focused on super fast hacking might be hyper successful and might create products that are used by millions. So uh, even that might be seen as craftsmanship. Now, how to optimize with Agile and craftsmanship? So first thing that's always very useful is focus on value delivered to customer, always mastering your tools, always removing things you can remove, simplifying things that you can simplify. I know it's painful that you have spent 2 months implementing some feature, nobody is using it. It was a mistake to implement it in the first time, or the situation has changed. So all of those things should be cut off from the application to simplify your life. Second thing, when you are picking a technology, you should base your decisions on value that will be provided and risks. But all of that have different, let's say, time scales. something that's useful for you today might not be that good 2 years from now and might be that good in 10 years from now. And changing things is sometimes very cheap and sometimes it's very expensive. What is cheap is changing management methodology. When uh, when you really decide that you want to change the way how you organize yourself, you can say, okay, I will do it. I will just adopt a new methodology, or we will have a new format for our user stories, or instead of user stories, we will use jobs to be done, and that's it. And now in 2024, you can ask ChatGPT to convert all of your user stories from existing format to a new format, and it can be done much faster than at any point in the past. While at the same time, exchanging, for example, your database is is difficult. Sometimes people say it's easy because it's behind ORM, so we will just change adapter. If this is true, it's quite likely that you didn't use all the features of your database, and it means that um, the choice of the technology wasn't very good because you should get as much value from each technology you use as possible. A side note, there might be situations where you are a software craftsman, when you are using technologies people are not thinking of or using that much nowadays. Like Delphi, if we think about Delphi, I was using Delphi in um, in 90s, and I remember I was able to drag and drop plenty of things. Like in one day, I could potentially drag and drop 30 screens and connect them to some data source. It was hyper productive. Of course, it was back in the day where all Windows applications looked alike. They're ugly, they're not responsive, they're not friendly for blind people, they're not friendly for people who have um, certain disabilities, for example, can't use keyboard and mouse, and all of that were are not, let's say, available for people. And Delphi wasn't helpful in this, but it was hyper productive for certain use cases. If your application was just a bunch of data grids and forms, it was super fast. And so in some situations, actually using Delphi, when you know exactly who will be your users, you know they will use Windows, you know that none of those users is blind, you know that it will be just data grids and forms. Using Delphi might be the fastest way to deliver something if you know Pascal really well. And when I speak today about knowing the language and mastering the language, at the same time, I would like to warn against being married to just one technology. It's it's great to be expert. It's really great, not just because uh, you provide more value, but it's also a good feeling, and it's an end stage of each software developer is becoming expert at something, be it a programming language database or, let's say, ability to administer servers. Not many developers have this goal, but there are plenty of people who, let's say, are in ops and still can do software development. And for them, it might be the goal. And I would like to say, not when you have a hammer, everything should not be a nail, and you should be able to work with multiple hammers. Next thing is, when I started software development 30 years ago, and for all the time, I believed that software development is very meritocratic, and people are choosing technologies because those technologies are the best. And I believed that developers are rational all the time. And I have learned that it's not completely true. there are fashions, there are bad habits in technology choices. I would like to speak about some of those. First is shiny object syndrome or novelty bias, where when something is new, it's seen as better, even when the old thing might be working perfectly well. I think it's less seen in some languages where there are, let's say, certain defaults. You don't see this that much in .NET ecosystem. You don't see that much in Clojure. At the same time, this thing have been quite common in JavaScript ecosystem. It has been common in databases or when you choose a database. Second thing is overscaling. So if Facebook or Google is using it, it doesn't mean you have to use it as well. It works for them. They are building and choosing technologies for their scale. If you have no users, you don't need technologies for millions of users. And even if you will succeed and you will scale your business or a product to millions of users, it will take years. Most likely it will take years, and you have plenty of time to change your choices and exchange technologies and architectural choices that don't scale. Another thing on the other side is not enough refactoring, having depth, tech depth in your code base. Uh, this is uh, this is something that's very common. Uh, in software development, especially when there is a vendor-client relationship where the client is paying per feature and does not have, let's say, a dedicated team that should maintain the product. So basically, every change in the product is done to improve visible business value for the customer. And when this happens, the product is neglected in ongoing, let's say, updating libraries and dependencies and overall refactoring. So this should be addressed. And next thing is uh, software development is R&D, research and development, which is somewhere in between manufacturing and research. Where in manufacturing, very often you know exactly what you are building, you know exactly what you need, you know exactly the steps, and you know exactly how long it will take. And on the other side, research is highly uncertain. You don't know if you will be able to deliver the product. You don't know how long it will take. You don't know what steps you need to do because you are doing something that's so novel that it hasn't been done before. And software development is in between. And there are things that are closer to manufacturing, like I have a friend or former colleague who is focusing on implementing websites on WordPress. And he is just creating websites on WordPress, and he turned this into manufacturing. You ask him to create a website, add a template, add contents, add plugins. He says, I will do it this evening, tomorrow morning, it will be running. And in those years, I know him, and I've asked him to set up a bunch of websites. He never lied, he never failed. It was manufacturing. On the other side, when you are building something highly experimental, your own programming language that's using aspects that have never been used in other programming languages, for example, you might be very unproductive. It might be super hard to say when it will be done. It might be super hard to say when it will be, uh, let's say, of quality to be used in real world systems and so on. So when you are deciding on what to do, you should think where you are on this scale, because when you are closer to manufacturing, you might be uh, you might be having more reuse. You might have, let's say, your product might be 10 modules you give to each customer, and 2 modules you write, let's say, in a bespoke manner. Or it might be the opposite, and it might be my research. We work on software for physical health device that will be novel, and such a device does not exist in the world at this moment. Even we are sometimes building against mocked interfaces, because some parts of this device does not exist. The hardware does not exist, only part exists. And in this situation, you have to approach development differently and do different choices. Now, um, at Flexiana, what we do is, I wrote a handbook. It's everybody can read it. It's published on our website. And the thing is, it's a North Star. It's something teams should achieve over time. So basically you can read the website, and you will see the what all teams should achieve over time, if they will have enough time and if they will grow enough. But they are free to ignore rules that are there, that are not relevant for their situation. Again, we are getting back to meritocracy. I am trying to uh, develop software and manage software development in a way where uh, it's the best solutions, the most rational solutions win. So it's handbook, and finally, after 1 hour and 12 minutes, we go to the last slide. And now it's a good time for questions. So, do you have any questions? Yes, Fernando?
Yeah. Well, how do you see? Remember the Frankie project
Yes,
that I saw with two devs, and I saw it with 20 devs. So,
yes.
do you think it's time that the teams change as a project restart? That you have to think about all the things again? What do you think about it?
Yes, so if we speak about Frankie, and it's true, there have been 20 closure and closure skill developers, and there are now 2 developers on this. It should have been 3 to 5 people the whole time. Frankie is our product. It's HR management software. Uh, Pro. It's all closure and closure script, fully implemented closure script. So I think it was a mistake to go to up to 20 people working on it. It should have been 3 to 5 developers the whole time, I believe. It would be much more productive. Speaking of the technology choice, um, closure and closure script was a good choice. At the same time, we have a portal, candidate portal, which is an independent application. So we are getting to the land of microservices, if you will, and and this was a mistake. It should have been a feature in Frankie. We should have built a separate application that is connecting through API with Frankie, because it got all of those disadvantages I was speaking about. So we basically change in one place means commits to 2 completely different repositories and pushing 2 applications to production at the same time. It's not that big problem. It's doable, but it's extra, something that is not adding any value. So I would say in Frankie we did some mistakes. But I see them in retrospect, and And I hope it's a lesson for other applications we are building. Okay. Other questions? Yes. Yes, Martina.
Are you now hearing in Flexiana?
If I am what in Flexiana?
Hiring.
Hiring. It's a good question. Yes, but at this moment we are hiring ClojureScript / TypeScript developers, and in Q1 2025 we might be hiring Clojure developers again. At the same time, we have a huge database of former colleagues who worked with us in the past, all of them in Frankie, and so we will be hiring, but at this moment only ClojureScript and TypeScript developers.
And how many years of commercial experience is required?
We evaluate, we evaluate only people with at least 5 years of professional experience. It doesn't have to be in ClojureScript. It should be, let's say, this is front-end development, so it should be in front-end development. But in general, if we speak about hiring to Flexiana, we don't even interview people who have less than 5 years of experience. And if they have more than 5, we are still looking at certain, let's say, skills, seniority skills that might not be just development skills. It might be skills related to ability to self-organize, to speak with the customer, to lead the team, even when we don't have any team leads and no managers in Flexiana, which means that I have another video on YouTube about this. We were it will be on our YouTube. So thank you. So basically we need people who can self-manage themselves, and not everybody is like this.
Thank you.
Okay, no problem at all. Okay, do you have any more questions? Okay. So if there are no more questions, I would like to thank you, and I hope this was all useful for you. And I hope you will come to the next webinar. Have a great day. Bye.
Bye.
Thank you.
Thank you.
Bye. Thank you.
Bye.